Hello, my name is Max Kashabo, and my project is building a model submarine. The reason why anything can float or sink is because of buoyancy. Archimedes' law states that the weight of any buoyant object is equal to the weight of the amount of water it displaces. I have prepared a small demonstration to show this. This block of
Max, move it a bit. Do you need help? Move it a little bit to the middle, so
if I
everybody.
do this.
Oh, okay, okay, no.
This block of wood weighs about 50 grams. Just tear this apart. When I place it in the water, the displaced water starts to drip out. 1 second. There we go. The displaced water starts to drip out. While that continues to drip, I can explain a little bit about the history of submarines. The first successful submarine was the Turtle. It was built during the Revolutionary War by the Yankees and was about 2 meters tall. Its plan was to swim underneath a British warship and deploy a bomb. The plan was unsuccessful because it only had about 25 minutes of oxygen and had to be propelled by manpower. Now we have the USS Pennsylvania. It is about the size of 2 football fields and has an unlimited supply of air due to electrolysis of water, which is when electricity is shot through water, breaking it up into its major components, hydrogen and oxygen. It also has almost unlimited fuel power due to its nuclear reactor, which has been running for over 20 years and shows no signs of needing to be refueled. This is, I think, about done. So, when I place it on the scale, it weighs exactly 50 grams, the same as this block of wood. This proves that the weight of the water that this block of wood pushes away is the same weight as the block of wood. The submarine that I built is made out of 3 PVC pipes, one larger than the rest. The first thing I had to do was find out the mass and the volume. So I knew how much water had to be added so that it would be heavier than water and could sink. The volume was 2,843 cubic centimeters and the mass was 1,683 grams. This would need tremendous amounts of water to sink, so I decided to add lead weights to each of the smaller tubes. The next thing I had to do was drill a hole on the bottom and the top. This would act as a ballast system. When I open up the top hole, water could come in through the bottom and the submarine would sink. When I blow air in through the top hole, the water is pushed back out and the submarine can resurface. I can now demonstrate that. Now when I let the air out, it takes a couple seconds to sink. Now, I have to try that again. This happened last time also. Because if this side sinks first, then it won't be able to sink all the way down, because the hole is on this side, and then the water can't go in. So I have to make sure that this side sinks first. Which I think it's doing. Yes. Oh, no. There we go. sunk, when I blow air into this tube, it should resurface again. Before I finish off, I would like to thank my mentor and my parents who have helped a lot during this project and made it a fun and educational experience. Thank you.